Hello, we are here for one more lesson of this T-FLEX analysis training course, and the topic for today will be the static analysis steps. So we will go through all the necessary steps to create this study for static analysis. So we have several steps. We have a diagram in our theoretical course that resumes all these stages, but we'll try to cover them here and see what each one of these steps makes and what is the purpose of each one of these steps. To show you this, I've opened one model that it was shown several times in some of the past lessons, but it's perfectly okay to show these topics. So first step to create the analysis is the creation of a 3D solid model of a part. So this is typically CAD environment. So we are at this time in the CAD environment. So we create, or we can create this rectangular shaped solid. Nothing in particular. We've seen this in several of the previous videos. It's a CAD function. Then step 2, it is something called create the study. So we go to the analysis and then we go and create a new study. Okay, something like this. And this is what initializes what we want. And in this particular step, we need to inform the system what is the type of study that we want to practice. So in this particular case, the static strength, it is the type of study we want to execute, because in static analysis we have other types of possible analysis like the buckling or the fatigue, but we are taking care of static strength in these first videos, a subgroup of the static analysis. In our particular case, we have already a study done. We can open our tree. So we have already a study. And going to the step 3, we need to define the material. So we have a special function for this functionality, where we can define the material with all its characteristics, and we have a database for this, or we can create our own materials and supply all these characteristics that we've seen already also in some of the previous lessons. After the material done, we need to create the mesh, and this finite element calculation needs always a mesh, and the mesh has some parameters. We've seen in one of the previous lessons also everything that goes along the mesh, the definition of the size of the mesh, and all these refinements that we can do to create the mesh. We have already a mesh done, so I will not recreate a new one. Step 5, it's what we call apply boundary conditions. And in static analysis, boundary conditions are represented by restraining methods and external loads applied to the system. When we are applying these conditions, you see that we have this item of the restraints. There are several types of restraints, being full restraints or partial restraints or others. And we have also some different types of loads we can apply to this kind of studies. So like force, pressures, rotations, whatever. There are a lot of them. And it is interesting because even in this static strength, we can apply or we can study the effects of temperature in static strain. So it's very interesting also this possibility. To make a study out of this temperature, when we create the solve, there is one thing that we need to, one thing or a group of functions that we need to supply to the system, which is this consideration of thermoelasticity, elasticity, and also these temperatures where we have zero strain, so non-stress state, and we need to define this temperature which corresponds to the no stress state of the model and defines this working temperature field. So we have already spoke about this, so nothing in particular. When we have all of these things defined, we go and run the calculation. So as I was simulating, we go to the solve, and the solve allows us to define a couple of generic things like this method, how we're going to solve also, the element type also, this possibility about considering the thermal effects or not, and the kind of results we want. So we have a list, and this list we can choose what we want to calculate. And in the end, this leads us to the step 7, which are the results, the analysis of the results. And the results are grouped, as you can see, in groups, several groups. Let us close these groups. So we have 7 groups, results, 6 groups. We have the loads, the displacements, the reaction forces, the strains, the stress, and the factor of safety. So there are inside these guys, there are a lot of different sub results for loads, for example. They are described in detail inside the theoretical course, but and you can see a little more about it, but it's important to have this idea that we have these results grouped by different types of results. And these are the steps that will lead to finish a study. Anyway, it is important to understand that when the result is finished, and in this particular case, I will create a calculation, and I will create a new one because I want to activate one of these guys by the equivalent stress. Okay. When we complete or when we finish the calculation, it's important to analyze the results that we obtain in order to make some conclusions on what will happen to the elements we are studying. In most of the cases, there are 3 types of solutions that are enough to see if we are going okay or not. And we can check the displacements, the stresses, and the strain safety factor. And we can go through these 3 types and see what happens. In terms of the displacements, okay, we in all of them we have values, but it's important also visually to see what happens and to see if they expect what we want in terms of the displacements or of what is possible to the system in what we want. And for example, in this particular case, as you can see, we can visualize the extremes, so we can check what will be the maximum displacement, and for this particular system we can check if it is acceptable or not. Then we have the stress analysis, where we can open the equivalent stress, and we can see the stresses that are present in the system. So it's another kind of analysis. So we can analyze in what locations and in which elements we have the largest stresses, where they develop. And we can compare also the maximum calculated stress with allowable stress for the model material, so that we can see what is going on. Finally, we can check one interesting study also, which is this factor of safety by equivalent stress, and this will give us the maximum value. We can see the extremes. We can see the maximum value for this stress being in tension or compression, whatever. And we can compare this maximum value to what we have defined for the material. So we have also this strength, tensile and compressive, and it is important to see if the value we calculated for the system it's near the admissible tensile strength for the material, and in fact if it is near of it, it's above these values, then we have to change something on the system, because the idea it is, or the conclusion is, that we are going to have problems with that design and with that material. So these are the steps that we need to go over in one static strength analysis. Any questions, any particular details that we might have skipped on this video, let us know your questions, and we will give you all the necessary support or additional explanations.